guys. Today, we're going to go really quickly through another example, exactly the same as yesterday. The only thing that's going to be a little bit different today is the x-intercepts, but that's like the very last thing we do. So I'm going to try to speed through the first part because hopefully you've got that down by now, and then we'll talk about how the x-intercepts are different at the end. You can print out the same worksheet that we used yesterday to do today's examples. We'll have 2 examples again today. So this one can go in that first spot, and then you can put the second video in the second spot. So please make sure to write down the original equation, y equals negative 1/2 x squared plus 2x minus 5. And we start these problems first by finding our axis of symmetry. In this problem, my b is 2, and my a is negative 1/2. So when I plug that into the equation, I get negative 2 divided by 2 times negative 1/2. Now I know that's a little bit scary because it has a fraction, but the fraction doesn't really do anything because 2 times 1/2 is going to be 1. So it's actually going to work out pretty nicely. And our axis of symmetry is going to be at x equals 2. Remember that this is an answer to a question. The question is, what is the axis of symmetry? The answer is x equals 2. And you can go ahead and graph that right now if you want to. Nice dotted vertical line going through the 2 on the x-axis. Next, we take the number 2 and we plug it into every x in the original equation. You can use a calculator, type it in exactly how you see it on the screen, or you can do it in your head. Just remember to follow PEMDAS if you're going to do it in your head. That means that you have to square the 2 before you multiply it by the negative 1/2. The y-coordinate for my vertex is at negative 3. But don't forget, we do need to write this as an ordered pair. So my final answer for the vertex is 2, negative 3. And you can go ahead and graph that. It should be on your axis of symmetry. Next, I have 4 answers that go very quickly, no work required. In fact, the only work we really have to do on these problems is calculating the axis of symmetry and calculating the vertex. So first I need to identify if A is positive or negative, and in this problem A is negative, it's this negative 1/2. So that means my parabola will be opening down. When my parabola opens down, it has a maximum or a highest point. My domain is always all real numbers. And then for the range, since it's opening down, I'm going to use a less than or equal to. I'm going to use the y number for my vertex. So my range is y is less than or equal to negative 3. Remember that these are 4 separate answers to 4 separate questions. Next, I'll do my y-intercept. Again, no work required. My y-intercept is just the last number from the original equation, this negative 5. Since it's a point, we'll write it as an ordered pair, 0, negative 5. When we're graphing, we should check and make sure that when we put a dot on the y-axis, that it's actually touching at the negative 5 where we said it was going to. Next, we're going to skip our x-intercepts and we're going to do graphing using our special ordered pairs. Now don't forget, we do need to multiply the y-coordinate by the letter A. And in this problem, my letter A is negative 1/2. Okay, so every y number needs to be multiplied by negative 1/2. We'll start with 1, 1, and that will change to 1, negative 1/2, or negative 0.5. So you're going to go over 1 and down just half a box. Make sure to reflect, so do it on the right side and on the left side. My next special ordered pair, 2, 4, is going to change into 2, negative 2. 4 times negative 1/2 is negative 2. Remember to put your pencil back on the vertex and go to the right 2 and down 2, and then reflect. Now here is where I put my dot on my y-axis. So I want to do a really quick check and just make sure that I put it on the negative 5. So 1, 2, 3, 4, 5. We did good. Now, I've ran out of space, but you guys should still have space to do your last special ordered pair, which is 3, negative 4.5. So remember to go back to your vertex and go right 3 and down 4.5 boxes. 4 boxes and then an extra half. Another good thing to check when you're graphing your parabola is make sure that it's opening in the direction that you said it was going to. I said this would be opening down, and it is an upside down view. So we did good there too. Now the last thing we need to do, we need to go back and we need to answer this question, what are the x-intercepts? Now the x-intercepts is where the parabola crosses the x-axis, which is up here. But my parabola starts down here, and it goes down forever. So this parabola will never touch the x-axis, which means that it has no x-intercepts. Since we're actually looking for where it crosses, it's acceptable in this chapter to write the word none. If this was our previous chapter before winter break, this would be a problem where we would get an imaginary answer because the x-intercepts do not exist. This is the end of our first example.